So welcome to all. In this video, we see the taper turning methods. So initially, what is meant by taper turning? So it is the uniform change in diameter of the workpiece measured along its length. It is the process of making the conical surface along the cylindrical workpiece, as diagram is shown in below. In this diagram, capital D is the larger diameter of the workpiece and small d is the smaller diameter of the taper, and L is the length of the tapered part, and A is the half taper angle. So there are different methods to produce the taper turning. So here there are four methods to produce the taper turnings. One is farm tool method, another one is tail stalk set over method, then compound rest method, then taper turning attachment method. First method, it is the very simplest method of producing a small taper in the given workpiece. The workpiece is initially fixed in the lathe chuck, then the workpiece starts rotates. Then the farm tool is grounded to the required angle. It is fixed below the workpiece. So then the farm tool is fed perpendicular to the workpiece. So the taper is produced. The taper length should be less than the cutting edge length. Then another method, tail stalk set over method. In this method, long workpieces with a small angle of taper is produced. In this method, we cannot produce more than 8-degree taper turning. So here the formula, set over H equal to capital D minus small d divided by 2L into capital L. So another we can write L tan alpha. So where the capital D is the maximum diameter of the workpiece, the small d is the minimum diameter of the workpiece, and L is the required length on which taper being made, and capital L is the full length of the workpiece. Here the workpiece is held between the centers and the tailstock is shifted from the lathe axis by the adjusting screws. Here the diagram, in this diagram, one end the workpiece is fixed with the lathe chuck, then another end we transfer the tailstock to another some distance in the lathe axis, that is denoted in the diagram H. So the workpiece is fixed between lathe dead center to the face plate or lathe dock. Then the tool is fixed below the workpiece. So then this kind of method is only for long and less tapering jobs. So we cannot produce more than 8-degree taper in the method. Then another method is compound rest method. So this method is for doing steep and short workpieces. So we can produce up to 45-degree taper in this compound rest method, but we cannot doing larger workpieces. It is only for short workpieces. In the compound rest method, this is the diagram shown in the presentation. In this diagram, tan alpha is the angle equal to capital T minus small d divided by 2L. So alpha is the half taper angle. In this method, we can produce more than 45-degree taper. So the workpiece is commonly fixed in a chuck. Then the another compound rest is tilted about some angle in vertical axis, then it is clamped in the some position. So the taper is turned by the hand wheel by rotating the handle. This method is employed for only short internal and external tapers with a large angle of taper. So we cannot produce more lengthy taper. What is the advantages of compound rest method? So this attachment can be quickly set. We can set the entire attachment in a short period. Tapers can be turned without disturbing the normal setup and aligned in of main parts of lathe. We cannot modify any major components of lathe. External and internal tappers can be tapered. So in this method we can produce more external as well as internal tappers. Long tappers can be easily produced in this method. Then the threads can be produced on the tapper surface. Accurate tappers can be easily obtained in a single setting. So we can produce the accurate tapping. The required angle of tapper we obtain in the compound test method. Then skilled labor is not necessary for this method. Then last one is tapper turning attachment method. This attachment is placed on the rear bed of the lathe with bracket, as diagram is shown in the presentation. This arrangement can be swelled to a maximum angle of 10 degree on either side. So both sides we can swell the arrangement about the 10 degrees. Then the formula for this method, S equal to capital D minus small d divided by 2L into Lg. So where Lg is the half of the total length of guide bar. So S is the number of divisions in mm. In this method, a taper turning attachment is attached to the rear end of the bed by using the bottom plate or bracket. It has guide bar which is pivoted as its center. So this guide bar can swing both sides about 10 degree, maximum 10 degree we can swivel the entire setup. So it has a guide block which connects to the rear end of the cross slide and it moves on the guide bar before connecting the cross slide. So the blinder screw is removed such that cross slide is free from the cross slide screw. So during the taper turning, the job is held between the chuck. The guide bar is made to the required angle. The formula is shown in below. By using this formula, we obtain the number of divisions. So S means number of divisions. Uh, when the longitudinal feed is given, the tool will move at any angular path as the guide moves at a angle on the guide bar. So in this method, we can produce the some required angle of taper. This is the four methods of taper turning methods. Thank you.